Determine the limit as x approaches positive infinity and as x approaches negative infinity of x squared times sine of 1 over x squared. Starting with the limit as x approaches positive infinity of x squared times sine of 1 over x squared, the first thing to do is try plugging a positive infinity in for each of the x's. Positive infinity squared is positive infinity times the sine of 1 over x squared, which will go to 0 as x approaches positive infinity. The sine of 0. The sine of 0 equals 0, given the positive infinity times 0 result. We have the infinity times 0 indeterminate form here. We will need to rework this. Since the 0 resulted from the sine of 0, we can make use of the identity limit as theta goes to 0 of sine of theta divided by theta equals to 1. Theta is the phase inside of sine. Here it's a 1 over x squared. It is going to 0, as it should be. We need to phase match it. In the other position, the sine is in the numerator, so we will need a phase match in the denominator. So we will isolate the sine, and we'll now phase match. Its phase is 1 over x squared, so we will put it over a 1 over x squared, and then to compensate, put a 1 over x squared out front in the numerator. X squared times 1 over x squared will be x squared over x squared. The x squareds can cancel. It'll be resulting in a 1. So we have 1 times the sine of 1 over x squared over 1 over x squared. 1 over x squared goes to 0 as x approaches positive infinity, and it is phase matched here, so it follows the identity, and that entire expression goes to 1 as x approaches positive infinity. The result is 1 times 1, which equals 1. Now to work out the limit as x approaches negative infinity of x squared times sine of 1 over x squared. The first thing to do is plug a negative infinity in for each of the x's. Negative infinity squared is positive infinity times the sine of, and 1 over x squared will go to 0 as x approaches negative infinity, so sine of 0. The sine of 0 is 0, giving positive infinity times 0. We have the infinity times 0 indeterminate form here. We will need to rework this. Since the 0 is once again resulting from the sine of 0, we can make use of the same identity. So we can isolate the sine, phase match it in the other position. It's in the numerator. We need a 1 over x squared in the denominator to match its phase. And we will compensate with a 1 over x squared in the numerator off to the side. The x squareds can cancel here, leaving a 1. Times the sine of 1 over x squared over 1 over x squared. 1 over x squared goes to 0 as x approaches negative infinity, and sine is phase matched here, so it follows the identity, and it will limit to a 1. The result is 1 times 1, which equals 1. And there's the results of the two different limits.